subtracting rational expressions. It's very much like adding and subtracting rational numbers. Okay? You're adding and subtracting rational numbers. Without a calculator. Before you can add fractions, they have to have what? Common denominator. Okay. So on this side, like this, the smallest they both go into is 12. So over here I multiply by 3 over 3. Why do I multiply by 3 over 3? Exactly. That's like multiplying by 1. This 3 over 3 reduces down to 1. And remember that identity property says that anything times 1 is itself. So even though it doesn't look like 1, I'm multiplying by 1. So I'm going to come up with the same answer. Okay? The same number. So that's actually going to be 3 over 12. And over here, I have to multiply times 4 over 4. So that's going to be 8 over 12. And then I add. When I add these, do I add the bottom numbers? No, you just add the top. I get 11, 12, right? Everybody remember that? You're like, oh yeah, I remember doing that. Yes. Okay. So we're going to do this today, but bigger, like much bigger, okay? Much bigger scale. All right. We'll start with a kind of an easy one. All right, so 5x over 48 and x over 15. I want to add these together. Really, this one's not so bad because I know there are x's in it, but they're in the numerator, so we really don't have to deal with those yet. Bless you. We're just looking at the denominator. And again. So I'm trying to find the smallest number that both 48 and 15 will go into. What? That goes into them. What do they go into? Now, okay, there are two ways to do this, and one way takes about a year. So you could say, all right, let me just list 48, 96, 134, no, 144. What's 48 before? 192. Like, that's horrible. Don't do that one, okay? That one's really bad. Because you have to list them all, because then you have to do 15, and you have to list all those multiples until you came up with some that matched, and like nobody wants to do that. An easier way to do it is to say, okay, that's 2 times 24, 2 times 12, 2 times 6, 2 times 3. So that one's 2 to the 4th times 3. That one's 3 times 5. Okay? I'm going to wait because you want to see this. It's magical. Okay? I'm going to let you get this written down because you're going to want to see it. Okay. So then I write them on top of each other with common multiples lined up. 2 to the 4th times 3, 3 times 5. So their least common multiple is whatever 2 to the 4th times 3 times 5 is. When they both share that factor, you only write one of them. That's why I like to line them up so I can bring it straight down. Because if you get them all off and crooked, it's hard to keep track. So 2 to the 4 is 16. 16 times 15, hang on. 240? Is that right?
Sure. Let's go.
Well, 16 times 10 is 160. Half of that is 80. So it's 240. Alright, so this side has to be multiplied by 5. And this side has to be multiplied. What? What? Kill it. Good. Okay.
So the common denominator is 51, right?
Yes. Alright, 25 plus 16. Come on, do some math. What's 25 plus 16? 41. That's not 41x under 40.
Where did you get like the 5 and the 16 from?
Because 5 times 48 is 240. And I need to make it be 240. And 15 times 16 is 240. Alright, you try one.
All of them.
No, not all of them. Some of them are bigger. Try this one. Okay. 24, 2, 12, 2, 6, 2, 3. So that's 2 to the third times 3. 36 is 2, 18, 2, 9, 3, 3. So that's 2 squared and 3 squared, right? So I'm going to write this one as 2 squared times 2 times 3. This one, 2 squared times 3 times 3. Alright. 2 squared times 2 is what? 2 to the what? 2 to the third. 3 times 3 is the same as 3 squared. So I need those to match so I can just bring one down. So one of those comes down. That comes down. One of those. Right there. What is that? 72. 72. Yes, it is. So a 24 gets multiplied by what?
3 and then 36 multiplied by 2.
Uh-huh.
And you get 9 miles, 72. 4 miles, 72.
Exactly. Here's something else I just want to point out. Notice what didn't get marked out On top, I didn't mark out a 2, and what did the 36 get multiplied by? And on bottom, I didn't mark out a 3. Yeah. Because what you're trying to do is you're trying to make up for what the other one doesn't have. Okay? Alright, so that's just fractions. Just fraction practice. Let me give you an easy one that has actual, like, expressions on top and bottom. Yep. And this way I'm going to get it written down before I start talking. Alright, so on the denominators, these are factors. Remember, these are like factors. And remember, I told you, well, the 2 from one got multiplied by the other, and the 3 from one, because you're looking for what they don't have to make the difference there. Well, this side has an x minus 3. What does it need? It needs an x minus 5. So I'm going to multiply times x minus 5, x minus 5. What does this one need? It needs an x minus 3. On bottom, on the denominator, leave it. Leave it just like that. You don't have to FOIL that out. You don't have to multiply that. You can leave it just like that. Save yourself some time. If you do multiply it out and you mess up, I'm going to count it wrong. So be good to yourself and leave it like that, okay? On top, we do have to multiply it out. That's going to be 2x squared minus 10x plus 3x squared minus 9x. X squared plus 3x squared, negative 10x minus 9x. Yes. I'm sorry? Yeah, some people think these are easier because you know right away what you have to multiply by. Some people like these better. And that doesn't factor. Like I can take out an x, but it's not going to change it. Okay? Alright, let me give you one to try. It's going to be just that easy. Okay, what does this side mean? M plus 4, M plus 4. So I'm going to have 2m plus 8. And what does this side mean? 6m minus 42. Oh, I don't know. So that's what, 8m with a 2, you would have to, it doesn't just reduce, it's this. Not that it just reduces, but that doesn't do anything for you. Now, I'm going to give you a warning. We'll get to the point where you have to factor the numerator because it'll cancel something out on the denominator. So you be ready for that, but this one doesn't. What? Yeah, get used to it, 'cause it's gonna happen. So, yeah, it'll happen. But this one didn't. But we'll get there. We will get there.
So
Okay?
you want us to do that every column number again?
When it can, do it. Yeah. Just get used to it. Get ready for it. Alright, let's see. I think we might, no we don't. Okay.